transistor. Transistor is a three-terminal device. Transistor is a three-terminal device which is used to control output. One terminal of transistor is connected with input, second terminal which is connected with the output, and another terminal of the transistor is used to control the output by providing some energy. Now, how we control output using third terminal. In this case, we can control output with the help of current or voltage connected to third terminal. When we control the output of transistor with the help of current, it is known as current controlled device. And when we control the output with the help of potential applied across third terminal, then it is known as field controlled device. And also voltage controlled source. So transistor will be of two types. One will be current controlled and another will be field controlled. So transistor has its two types. Current controlled and the is field controlled. In current controlled device, it is BJT, Bipolar Junction Transistor, and when it is controlled with the help of voltage, then it is known as field effect transistor. BJT is of two types, NPN transistor and PNP transistor, while field effect transistor has several types like JFET, junction field effect transistor, MOSFET, JFET will be of two types, N type and P type. MOSFET is of two types, depletion type MOSFET, and enhancement type MOSFET. JFET stands for junction field effect transistor. MOSFET is metal oxide semiconductor field effect transistor. In depletion type MOSFET, there are also two types, N type and P type. Enhancement type is also of two type, N type and P type. In this lecture, we will discuss about bipolar junction transistor or BJT. So let's start about BJT. Then our first topic is BJT. BJT, bipolar junction transistor. Bipolar junction transistor, when P type or N type semiconductor material is sandwiched between two N type or two P type semiconductor material, then new device is known as NPN or PNP, bipolar junction transistor. Why it is known as ट्रांजिस्टर? हम इसे ट्रांजिस्टर क्यों कहते हैं? Why it is known as transistor? First reason, it transfers the resistance during its operation. It means it's transfer the resistance, so that's why it is known as transistor, transfer of resistance. Second, it has three terminal, as in diode. There are only one and two terminal, but in transistor there is three terminal. In transistor there is three terminal. See how? First terminal, second terminal and third terminal. This is our BJT, model of BJT, and in this we are saying that first terminal, second terminal, third terminal, in which one terminal is connected to input, and there is connected to output, and third one connected to control the amount of output. This is known as emitter. This is base, and this is collector. Let's go in detail for PNP and NPN junction, NPN transistor. Then I have taken a sample of p-type semiconductor material and sandwiched n-type semiconductor material between them. This is metal contact. In each semiconductor material devices, there are a metal contact provided to uniform distribution of the field. There is uniform distribution of field. So that's why we use metal contact. Now, this is PNP, bipolar junction transistor. So that's why it is p-type semiconductor material. This is also p-type, and this is n-type semiconductor material, in which it has larger number of holes in comparison of collector, but the area is moderate. Density of holes or charge carrier in this region is higher than the density of charge carrier in collector region. Always remember that. Charge carrier inside emitter is higher than the charge carrier inside collector. Now, few holes inside p-type semiconductor material. Now, electron as a minority charge carrier present inside p-type semiconductor material, so that's why it is represented by black dots, and n-type semiconductor material. This is known as emitter. This is base. This is collector. This is our PNP, bipolar junction transistor. Now, its symbolic representation. How can we represent BJT in symbolic form? Then this region is representing base, denoted by capital B. This region is denoting emitter, and this is denoting collector. Now, if arrow is towards the base from emitter, then it is known as PNP, and when arrow is away from the base, it is known as NPN, base, collector and emitter. This is NPN, bipolar junction transistor. There are two junctions. This one is collector base junction, and this one is emitter base junction. Sometimes it is also known as emitter junction, and it is known as collector junction. Now, what is the specialty of emitter? So, emitter consists highly doped region. This is highly doped region which emit the charge carrier towards the collector. So that's why it is known as emitter, but area is moderate. Collector is the region a bipolar junction transistor which collect the charge carrier, which is less in the density of charge carrier, but area is larger and the base has a narrow width, very narrow. Just you can suppose that it is only used to provide the gap between emitter and collector. Base is lightly doped region and its area is too small. If the area of base is larger, then all the charge carrier emitted from emitter will be recombined in base region, so that's why all the current will lose through base. It will not allow the flow of charge carrier through collector. So that's why area of the base should be small. Base area is too small, as we can do that. Okay. Now, just operation. We are going to discuss about the operation of the transistor. So here there are PNP and NPN transistors, so that's why it is difficult to decide how can we polarize bias that transistor. So there are several things. Emitter base junction. Emitter base junction should be forward bias, while collector base junction will be in reverse bias. That's why we apply the forward bias to this region and reverse bias in this region. After biasing the transistor, when emitter base junction will be forward bias, so we can say that here p-type, n-type, one diode, and n-type, p-type, and the diode. This will be in forward bias, so width of depletion region at this junction will be too small, and in case of reverse bias, the width of collector base junction will be larger than emitter base junction. So here width is small, so that's why resistance is less, and here width is larger, so resistance will be larger, so resistance high. In that case, charge carrier going through the emitter to the collector will suffer from lower resistance to higher resistance. It's mean here the charge carrier are moving from lower resistance region to higher resistance region, so here the transfer of resistance is being placed, so it is known as transistor, transfer of resistance. Okay, is it clear to everyone? I think so. Now we will discuss in our next lecture how to supply the current of voltage through bipolar junction transistor. One thing more, why it is known as bipolar junction transistor? So let's see a view. Bipolar junction transistor, bipolar junction transistor. Here it's not only two junction due to which we are naming that bipolar. No, charge carrier. Main thing is charge carrier. In any region we are saying that from this region hole has a majority flowing towards the collector, and in base region electrons, free electrons are as a majority charge carrier, and here also hole. So two types, electron, free electron, and holes, both play their role in current. So it is known as bipolar junction transistor. If only holes or majority charge carrier are playing their role. In that case, the device is known as unipolar. That's when types of charge carrier. From here holes and from here electrons. Both are participating in the flow of current. So that's why it is known as bipolar junction transistor. And one thing, when we are applying positive, it is connected to ground respectively, and this is connected with negative. In that case, you will observe that all the hole will be repelled by positive sides, so it will move in this direction, and these holes of collector will also move in the same direction, and electron will move in the opposite direction. So see here, we have made a representation towards base from the emitter, okay, and through which it is going to collector. So that's why we can conclude that this is representing the motion of charge carrier.